Hello everyone and welcome to Key Skills Tutorial 3, which forms part of the SE 4030 Key Skills for Chemists modules, although other programs may watch this. What I'd like to do in this Key Skills tutorial is discuss how we can write laboratory reports, think about some of the important parts of laboratory reports, and hopefully give you a few hints and tips on how to get the best mark possible when writing laboratory reports. So the first question we've got to ask is, what is a lab report? Well, it's a way to explain exactly what you've done in an experiment. It will describe the results you've obtained, and it will also discuss what you've learned in a particular experiment. And it's a very important document, and it's a very important part of scientific practice and indeed the scientific process. So we don't just set these as busy pieces of work, right? We don't just set them to give you something to do. They're incredibly important documents, and they form really important parts of academic research. So in academia, we are constantly writing formal laboratory reports in the form of scientific papers. They form a very important part of the chemical industry. So it may be that some of you go off and work in the chemical industry, and you need to conduct a series of experiments for a given project, and you need to efficiently describe what you've done and state what you've learned and report that back to your line manager. And more often than not, this will be in the form of a laboratory report. They're also important for technical roles and any other roles where you may come across chemical literature. They help us to communicate the major points of an investigation to other scientists and colleagues. And of course, they're a very systematic way to spread the information that we learn from a given set of experiments. Now, this is an important point here about style and format. So I think it's very common for students to come to us having possibly studied more arts-based subjects like history and English. And indeed, I know that when I was in school, we were kind of taught to write poetically and with a bit of artistry. But that's not the point here. And I put up War and Peace there with a big red cross over it because when we submit a laboratory report, we do not want War and Peace. And here, quality is definitely the main point. So quality over quantity. Lab reports should be very clear and accurate documents. They should convey that information in as concise and clear a manner as possible. And so you should be at about a maximum of 2 to 3 pages in length for a laboratory report. And indeed, any kind of huge excessive background or intensive explanation is not necessary here. So we've got to get to the major points very quickly. So if you've been working on an experiment that involves tin oxide, for example, in the laboratory, the reader does not need to hear about the discovery of tin or the uses of tin in ancient Egypt. It's not important. We need to get to the important points as quickly as we can. Now, we should never use personal pronouns in a laboratory report. We are scientists and we must stand back from our work and take an objective view of the observations that we make. So we cannot make it personal. So you should avoid the use of things like I, we, and you. So here's an example. Instead of we took 3 ml of 1 molar hydrochloric acid and added it to our beaker, you should write 3 ml of 1 molar hydrochloric acid were added to a beaker. So you see what I've done there is remove any kind of personal pronoun from the writing. Now I see this quite a lot in laboratory reports, and students sometimes make this mistake. You see that in a conclusion, somebody might say, I learned that when you take salt water and place it in a container with fresh water, the salt water will sink because I know that salt water is denser than fresh water. Now, we've got to reword that slightly if we were writing a laboratory report, and we've got to make it more concise and more efficient, but also remove any of that kind of personal information. So we would rewrite that as, in a container, salt water will sink below fresh water because salt water is more dense. And of course, as in all writing, proper grammar, spelling, and punctuation are important. And you should always avoid using slang. So I don't want to see anybody saying that I chucked a gram of sodium chloride into the beaker. Now, these are technical documents, so we've got to use the correct technical terms, and graphs and tables should be incorporated within the body of the text. So we're not going to form large appendices and place all the graphs at the end of the document and make it difficult for the reader to link our text with figures. We want to incorporate those graphs and tables within the body of the text so that the reader comes across them as necessary. The general structure for a laboratory report is shown here. So there should be a title page, and that makes the document an official one. There should be an abstract, and we'll talk about all of these sections in a moment. There should be an introduction, a materials and methods section, a results section, a discussion section, a conclusion, and some references. So the title page then, it's a cover page to your report. It makes the report easily identifiable, and it makes it an official document. It should have the title of your experiment, your name, and for the time you're with us at the University of Chester, your student number. And crucially, it should have the date the laboratory was performed. So if there were any anomalous results, for example, and it just so happened that the weather was very cold on a particular date, and that impacted on the results, then you can look back and check and cross-reference this with the weather. This may explain why you get any anomalous results. The date is very important. And often you'll see in the undergraduate experiments here that you will be given an experimental title. But if you are not given an experimental title, and this holds, if you guys are working in industry or research, then you should try and make that title very succinct and catchy. So it should be 10 words or less. And whether you're working in academia or in research, you want to make your report easy to find, so that when someone types it into a search engine, whether that be an internal one or if you're publishing work, Google Scholar or Science Direct, you want to ensure that your report starts with a keyword. So avoid the use of things like a, an, or the. So the abstract then, this can be a tricky one to write and takes a little bit of practice. So these are a completely self-contained way to briefly summarize the procedures, the results, and a snapshot of the conclusions of your report. And when other scientists are reading through the chemical literature and they come across possibly hundreds or even thousands of reports or papers, they need an easy way of very quickly seeing what any one individual paper is about. So often you'll find, and you'll see this as you read the chemical literature, as you're searching through lots of different papers and reports, you'll very quickly read the abstract, and that will immediately tell you whether or not you're interested in reading that paper in more detail. Of course, if it bears no relevance to the work that you've done, then you can cast it aside and move on to the next one. And these are usually a single short paragraph that's written in the present tense. And what I do is I urge you here to watch Key Skills tutorial 4, where I discuss searching for chemical literature and referencing chemical literature. And again, find some papers that you're interested in. Pick an area of chemistry or materials science or nanoscience that you're interested in. find some research papers and reports surrounding those topics and get to grips with how these things are written. They will all have abstracts. So have a look at some examples and see if you can start replicating them in your laboratory reports. The abstract appears right at the beginning of the laboratory report, so it appears right after the title page. And I would recommend that you actually write the abstract after you've written the rest of the lab report, because you have a nice overarching view of the experiment and the conclusions that you draw from the data. So the introduction then, another important point, it explains the purpose and the objectives of the experiment. And it provides the reader with a bit of background discussing the what and why of a particular experiment. So you can begin with a bit of prior knowledge on which the experiment is based. That's absolutely fine. But again, we don't want to go into too much detail. Crucially here, then, you're explaining the purpose of the experiment. What are you trying to find out? You will explain why the experiment was conducted in a certain way. So you justify the methods that you're using in the particular experiment. You may have an experiment that could be done in several different ways. Well, you have to justify why you've chosen to do it in the way you've chosen to do it. And you will include here, this is where you will include some background information from textbooks and research articles. And again, be careful not to plagiarize. You also want to get some sort of hypothesis into the introduction, so state what you think the experiment will show. The materials and methods section is very important. It explains exactly what you used and how you did it. So it explains the materials you used in terms of the chemicals and the equipment that you've used. And when you're in the laboratory, you should note down any chemical manufacturers that you can see. You should note down the make of the equipment you're using, and you should tell the reader this. You should then, in a very detailed way, report exactly what you did in the experiment. And this section should be highly detailed. And part of the scientific process then is performing an experiment, drawing some conclusions and reporting your results. And then other scientists are able to attempt to replicate your experiments or indeed expand upon them. So the whole point of this materials and methods section is that another scientist should be able to reproduce your experimental methods and obtain exactly the same result as you did. And then, of course, the scientific body of knowledge increases when other scientists expand upon the work that you've conducted. Okay, so the materials and methods section has to be written in quite a specific way. It needs to be written in a way that demonstrates you have a good understanding of the experimental procedure that you've used. Really important here, and this is why I've highlighted this in bold, it needs to be written in the third person and you must use the past tense. It might be helpful to include a diagram of your experimental setup, and you're more than welcome to get these from Google or any of the lecture materials or textbooks that you are using. Please just make sure you reference them properly. I find it's often quite helpful in laboratory reports to include a diagram of your experimental setup. One thing that I really don't want to see, and one thing that is really bad practice when writing a laboratory report and looks really unprofessional, is when people draw pictures of an experimental setup and take a picture of it with their phone. It just looks really amateur and really unprofessional, and is not becoming of good scientific practice. So on the left there, I show you an example of a bad diagram for a filtration setup. On the right then is a much better diagram. It's much clearer and it looks much more professional. So once again, you can use diagrams from the web, just make sure you reference them properly. The results section then is where you should include any data and any observations, and they can be quantitative or qualitative, that you made in the experiment. Any quantitative data should be represented in a table or a graph, and I would urge you to think very carefully about the most efficient way to present your data. So if you have reams of data in a table, it may not be very efficient to simply include the table in your report, and you may wish to present that in graphical format because it's much more readily interpreted by the reader. You've got to give any diagrams titles and numbers, and the general convention is to use figure numbers. So I show you here an example of a figure 1, for the pH variation over time for 3 tests, so test 1, test 2, and test 3. And you'll note how carefully I've labelled the graph here. So not only are my axes legible and clearly labelled with units, in the case of time for days, but also I've got 3 different experiments there, test 1, 2, and 3. And you'll notice in the figure caption that I've told the reader that test 1 corresponds to the crosses, test 2 corresponds to the diamonds, and I've got a control experiment which corresponds to the squares. So please make your figure captions clear, make sure you label your axes with the correct units, and most importantly, make sure they're legible. Make sure that these axes aren't bunched up. Once again, I would encourage you to engage with the scientific literature. So again, go to Key Skills Tutorial 4, take a look at searching for scientific literature, find some areas of chemistry that you're interested in, download some papers, and have a look and just get comfortable with how data is presented within the chemistry setting. So again, just to hammer this home, if you do create a graph, you've got to make sure that you label the axis. And there are some, you can find this in the mathematical skills tutorial on graphs. The dependent variable will always go on the y-axis, and this is often the variable that you're measuring. The independent variable will always sit on the x-axis. So this variable won't change based on another variable. A good example of that is time. But take a look at the mathematics tutorial on graphs. For tables then, make sure you label the columns and rows and make sure you include those units of measurement, otherwise the numbers in your table mean absolutely nothing. Tables have to be clear and concise, and most importantly then, don't use a table when a graph may represent the data in a more reader-friendly manner. And this is really, really important. The amount of times I see undergraduate students present reams of data in a table, and tables of data are very difficult to interpret. So a much more efficient way of presenting data is to present it in graphical format. So I'd urge you to think very carefully about that. Now, some laboratories require you to make mathematical calculations with your data, so particularly some of the phys-chem laboratories. And an important point here is that if you're using the same calculation for several points of data, then just demonstrate the mathematical process a single time as an example of what you did. So if you're conducting a calculation and you're using several data points, don't show me the calculation for every single data point. You only need to demonstrate that you can do it with one, and then you can include the rest of the data in a table or in a graph. So take a look at the yellow box there. I show the reader at 25 degrees Celsius, the number of moles of gas was calculated as. I demonstrate my ability to perform the calculation, but then I tell the reader that the rest of the data in the mass column of figure 2 were found using this same calculation, and that's a very important point. Present calculations using an equation editor. So again, this is another important point. Don't write out calculations using Microsoft Word. There is an equation editor in Word, which is very good. You can't show, some people will show a division with a forward slash, or they will show a multiplication with an X. You've got to use a proper equation editor, and you can find that in Word or PowerPoint. Again, Please don't write the calculation and take a picture of it on your phone. It's unprofessional and it looks very amateur. So the results section then is only information that is recorded when you conducted the experiment. There is no need to give any interpretation of the data here. You're just presenting the results. Only include the information that you found when you did the lab. We don't need to know about anything else. Make no comment on what you expected to find. And again, this section should also be written in the third person past tense. Okay, so the discussion section. Logically think through your data and interpret it. What does your data show you? Do your results support your original hypothesis? Do they support the stated objectives of the lab? If you haven't met your objective, that's fine, but tell us why. And if your results don't support your original hypothesis, that's also absolutely fine, but tell us why. If you do obtain an unexpected result, then you've got to think why you've obtained an unexpected result. Did the equipment malfunction? Was the temperature in the lab too low and you obtained a very low yield? Did someone drop a beaker and smashed a product all over the floor? It doesn't matter if nothing works correctly in a laboratory. You can still get an excellent grade in the lab report. You just have to justify it and explain what might have gone wrong. In your discussion, then, you should bring in literature references that support your discussion. So you will be making a conclusion based on the data that you've obtained, and if that's backed up by work that's been done by other scientists, then you should bring that in there to add a robust weight to your argument. Again, continue to write in the third person past tense and avoid any opinions or emotional language. The conclusion then is often a simple single paragraph. It's a very brief summary of what happened in the experiment, and again, you should just reiterate whether or not the experiment supported the original hypothesis. Again, in the conclusion, you should briefly restate any errors and any that caused any unexpected results. And the conclusion then should mirror the introduction. It should finish off the text nicely and briefly remind the reader of any findings from your experiments and their implications. Finally, the referencing style. You should list all literature that's cited at the end of the report. Again, I encourage you to go to the Key Skills tutorial on literature searching and citing. And the university states that APA referencing is its preferential referencing style. I'm not worried about what referencing style you use. You can pick whatever referencing style you like. You may like the Royal Society of Chemistry referencing style, for example, is the one that I use. The only thing that I urge you is to make sure that that referencing style is consistent throughout the report. So if you have 10 references in a laboratory report, I don't want to see the first 3 as APA, the second 3 as the Royal Society of Chemistry, and the third 3 as the British Medical Journal. They've got to be in a consistent referencing style. And again, make sure you search for the literature in the correct places. Watch Key Skills tutorial 4. And again, in Key Skills tutorial 4, I show you, I introduce EndNote, which is the reference library or the reference management software that I use. You have access to this through the University of Chester, and I would recommend that you use it. If you start using it now, it will stand you in good stead for your final year when you come to write your dissertation. There is another reference management software. It's called Mendeley, and it's quite good. Personally, I prefer EndNote, and you get EndNote through the university.